angle is 90 degree. That means ABC angle equals to 90 degree. This one is 90 degree, right? So just look at here. If this angle is 90 degree, and I am writing here. First we will prove that if this angle is I, then this one is also I. How? Because A dashed A dashed AB equals to 90 degree. A dashed AB equals to 90 degree. Why? Because this is the direction of wave and this is the wave front, initial wave front, right? So A dashed AB means we can write A dashed A, suppose this is N1 into normal. A dashed A N1 plus N1 AB plus N1 AB equals to 90 degree. Now this angle is also 90 degree. That means N1 AC, because this is normal and this is surface, reflecting surface. So angle N1 AC equals to also 90 degree. Now N1C means N1 AB plus BAC equals to also 90 degree. So just add these two equation. If we compare these two equation, then this is I, right? So I plus N1AB equals to N1AB plus BAC. So this is cancel. So BAC equals to I. Next, we will prove that if this angle is R, then this one is also R. Just look at here, N1AC. N1AC equals to 90 degree, right? Just I am writing here, N1AC equals to 90 degree. We can also write N1AC equals to 90 degree. We can also write N1AP plus, just look at it, N1AP plus PAC equals to 90 degree, right? Now N1AP means R, so we can also write R plus PAC equals to 90 degree. Now next, just look at here. That means in this triangle, just look at it, in this triangle ABC equals to 90 degree, right? ABC equals to 90 degree. If in this triangle this angle is 90 degree, then that means sum of these two angles should be 90 degree. That means we can also write here PCA plus PAC equals to should be 90 degree. So just compare these two, then we will get R plus PAC equals to angle PAC plus PCA. So just look at it, PAC cancel. So PCA equals to R. Okay, so that means this angle is I and this angle is R. So just look at here, if we compare APC triangle and ABC triangle, if we compare APC triangle and ABC triangle, just look at here, APC triangle, this angle is 90 degree, and ABC triangle, this angle is 90 degree. That means this angle equals to this angle. And okay, So these two angles are equal, and this is the common side, right? AC is the common side between these two triangles, that means ABC and APC. And also AP side equals to BC side. That means from side angles law we can say that APC triangle congruent with ABC triangle. So if these two triangles are congruent, then these two angles should be equals. That means I equals to R. And this is the second law of reflection, right? So we prove that the second law of reflection by using Huygens principle. Next, I will discuss about interference of light. So basically, what is the meaning of interference? So if we take two sources, then this source generate waves and this source is also generate waves, and we can observe at here these two waves interfere, okay, where these two waves interfere like this, that is called like this, or if two waves interfere like this or like this, then this both cases we can say that this is the constructive interference. Why? Because in these two cases the amplitude of vibration increases, right? But if the two waves, where these two waves interfere like this, in this case the molecule becomes to rest. That means this is called destructive interference. Just look at here. Here I am taking this is crest and this is trough. So where two crest interfere to each other, then if two crest or two trough, if two crest or two trough interfere each, here two trough interfere, two trough of two waves, two trough interfere to each other, and here two crest interfere to each other. So that means if where two trough or two crest interfere to each other, then that is called, or that point, constructive interference. That point is called that is called constructive interference. And if one trough and one crest interfere to each other, then that is called destructive interference. Just look at here. Here I am pointing some points. Just look at here. This is the crest of this wave which is generated from this A point. Suppose this is source A and this is source B. So this is the first crest of wave which is generated from A point, and this is trough. Again this is crest and this is trough, like this. And wave generated from B point, the first crest is this one. This is first trough, then crest, then trough, like this. Okay. So just look at here. At this point, at here, the crest of this A wave interfere with trough of this B wave. That means this is destructive interference. At here, two trough of this two wave interfere. Just look at here. This is this trough and this trough interfere at this point. That means this is constructive. Again, this is destructive because the crest of this A wave interfere with the trough of this B wave. So this is, that means, sorry, just change this, P source and Q source. Okay, this is P source and Q source, and this is A point. This is A point, B point, C point, D point, and E point. So A point is, just look at here, A point is destructive interference. Destructive. What about B point? Just look at here, B point is constructive. Two trough interfere. Constructive. C. What about C point? Just look at here, C point is also destructive. What about D point? This is C, this is D. D point, just two trough. Just look at here, this is also trough and this is also trough. So D point is also constructive. E point is again destructive. E point is again destructive. Okay. Now I will discuss about double slit experiment. Okay. So in double slit experiment we can observe interference pattern. Interference means if we take two source, then interference pattern we will observe. But if we take more than two source, then we can observe diffraction phenomena of light. But in double slit method we can observe only two sources are exist. That's why double slit experiment gives us interference phenomena of light. In double slit experiment we can observe interference phenomena of light. Okay. So now I will discuss about when constructive or destructive interference create. So let us assume that displacement of P point, just here I am taking, this is the double slit, just look at here, slit number 1 and this is the slit number 2. Okay, and this is the screen, this is our screen, and here I am taking a point P on the screen, and here we will find out the when at P point interference is constructive or destructive. What is the condition? Then we can get constructive interference at P point, and or we can say when we get destructive interference at point P. Okay, when we observe destructive interference at point P. So just look at here, let us assume that displacement of P point due to a wave coming from first source. Here this is a source number 1 and this is the source number 2. This is two source of wave. Okay, so the light coming from first source, this is the direction of light. So light coming from first source, due to this light, the P point Y1 is represent displacement of P point due to the wave which is coming from first source. Okay, and displacement of P point due to wave coming from second source is suppose Y2. Here I am assuming that Y1 equals to A cos omega t. A is the amplitude of this wave, and here I am assuming that after t time this wave reach at P point, and omega is the angular velocity of this wave. Second, Y2 equals to A cos omega t plus phi. What is Y2? Y2 is the displacement of P point due to the wave which is coming from second source. So this is the equation of Y2 and this is the equation of Y1. Here phi represent phase difference between these two waves which are coming from 1 and 2 source at point P. That means when the source reach at P, when the source from first when these two waves reach at point P, then we can observe they have phase difference which is phi. So phi is the phase difference of these two waves when they are reach at point P. So just look at here, the net displacement of P is y equals to y1 plus y2. So this is the value of y1 and this is the value of y2. So if we take A common, then cos theta cos A plus cos B, and cos A plus cos B, or we can say cos theta 1 plus cos theta 2 equals to 2 into cos theta 1 plus theta 2 by 2, that means omega t plus phi by 2 into cos theta 1 minus theta 2 by 3, that means omega t minus phi by 2. Finally, we will get 2 into A cos 2 omega t plus phi by 2 into cos minus phi by 2. Now 2A cos phi by 2 into cos omega t plus phi by 2, because cos of minus theta equals to cos theta. This is represent amplitude of P point, right? This is represent amplitude of the wave which is formed by superposition of this two wave. That means if this wave is reached at point P and this wave is reached at point P at the same time, then obviously these two waves superimposed at P point, and due to this superimposition of these two waves we will get a new wave, and this is represent amplitude of that new wave. Okay, so 2A cos phi by 2 represent amplitude of P wave of P point which is depends on the phi. So if 2A cos phi by 2 equals to 0, then it's called destructive, right? That means when these two waves reach at point P, and then if the amplitude of P point, the amplitude of vibration of P point, we can say this is the amplitude of vibration of P point basically. So if the vibration of P point is 0, that means it show that this is the destructive interference, right? And if this is maximum, that means 2A cos phi by 2 equals to maximum, then it's called constructive interference. That means the P point, the magnitude of vibration of P point is, if the magnitude of vibration of P point is maximum, then it show that the interference is constructive, right? So that means this is maximum, means 2A to fixed, 2A cannot change. Why? 2 is the numerical number and A is the amplitude of each wave. These two waves have same amplitude which is A, so it cannot change. So only this form can be changed. So if cos pi by 2 equals to plus minus 1, then this is maximum, that means constructive interference. So that means phi by 2 equals to, phi by 2 can be 0 degree, 180 degree, 360 degree, 540 degree, all this. That means so phi equals to 0 degree, 360 degree, 720 degree, like this. That means we can also say that in radian phi equals to 0, pi, plus minus 2 pi, plus minus 4 pi, plus minus 6 pi, all this. And what about path difference? Just look at here. This is a relation between phase difference and path difference. We already studied about that in class 11. So this is path difference between two light, which is equals to lambda by 2 pi into phase difference. So when phase difference is 0, then the path difference is 0. When phase difference is 2 pi, then path difference is lambda. So if x equals to 0, lambda, 2 lambda, 3 lambda, all this, for all this path difference, we can say that the interference is constructive. What about destructive interference? When cos phi by 2 equals to 0, then destructive interference, right? That means then this is becomes to 0, then the P point is in rest, that means this is destructive interference. So that means phi by 2 equals to 90 degree, 270, 450, all this. That means phi equals to 180, 540, 900, all this. So phi equals to plus minus pi, plus minus 3 pi, plus minus 4 pi in radian. That means x equals to lambda by 2, 3 lambda by 2, 5 lambda by 2, all this. Okay, so these are the condition for constructive and destructive interference. Now I will discuss about fringe width and all these phenomena about double slit experiment. So just look at here. I'm going to prove this in lambda equals to x d by d. What about all this? Just look at here. This is double slit experiment here. This is a two slit, and light rays are monochromatic. That means light source is monochromatic. That means monochromatic means same type of light rays coming here from this source. We cannot take white light, because if we take white light, then the fringe which are observed in the screen, which are observed on the screen is not bright. There, that means there, because white ray means sum of 7 color, right? That means all the rays overlap to each other, and then the fringe is not bright. Okay.